mechanics or electrodynamics.
Okay, well, so some of these are mixed together, or some topics mixed together. But the point I'm trying to make is, superficially, these all look different. But from the outside, they're separated by different topics. They appear to just be different ways of looking at the universe. But we live in one universe, or even if we live in if the multi-universe exists, there's still one giga-universe. So coming from one source. So all of these are related in some way. We all live in one universe. These are one. So even though they have different frameworks, like the separation between them is just an illusion. All is one and one is all, following this principle. So the goal of our class and physics in general is to see what happens when we start combining these frameworks, when we start breaking down the separation between all these subjects. So, for example, we saw already how electricity and magnetism, or electrodynamics, looked completely different from classical mechanics. But once we tried to unify them, once we found a way to connect them together, we came across some startling discoveries, such as the universe is actually four-dimensional, and time is the fourth dimension. And that's where relativity comes in. So by combining these two, we found relativity. And hello. So we're just talking about how physics being separated into different topics is a lie, and in reality, it's just a part of our ignorance. So what happens? So earlier on in the early 1900s, we saw in the other classes that when we combine electricity and magnetism and classical mechanics, in order to combine them, for make these two frameworks to work, we need to treat time as a spatial dimension. So we set up a framework where our universe is in 4 dimensions, and a lot of weird things came out, such as time dilation, length contraction. So by combining these two seemingly unrelated parts of the universe, aspects of the universe, we get all these surprising and fascinating new insights or new discoveries about the universe. So that's what we're going to try to do here. So the ultimate goal of this class is string theory, which that's just quantum mechanics plus general relativity. Equals string theory. So we saw last time that general relativity locally could just be special relativity. There's special relativity plus gravity. And now, using the addition property of mathematics, we could say that quantum mechanics and special relativity, when we combine them together, we get quantum field theory. So all string theory is quantum field theory plus gravity. And many remarkable things pop out when we combine special relativity and quantum mechanics together, such as we saw earlier, the Casimir effect, where 2 parallel plates attract each other really close together in a vacuum. So to kick off this whole unification, and we're still in the process of unifying this. This is not the final answer. There's much more to be done besides string theory. There's much more to come after string theory. But so we're just gonna kind of build a path to this. We're gonna build a path from quantum mechanics, special relativity, quantum field theory, gravity, string theory. We're gonna show this path. So I know some of you haven't taken electricity and magnetism at an upper level, and that's fine.